Hi Steve, hope you're well. My name's Matt, and I've got a question, or a couple of questions actually, about our warm roof. It's quite a complicated design. This is the architect's drawings that he drew up 3 years ago, but quite a lot has changed since then, and also this drawing is looks quite detailed, but when you actually look at it in closer detail, there's a few things that are wrong with it. For a start, there's no fall on this roof, and so we've addressed that. Perhaps it's easier if I show you a photo of what we've got at the moment. So this is what we've got. That's the main house there, and this is the extension. And I'll show you in 3D what it actually looks like. This is my drawing in 3D. So the actual main house is this white kind of rectangle here. As you can see, the extension doesn't meet the house. So what we've got is we've got some glass, 2 meters of glass that comes across here, and then we've got a vertical, and it rests on this upstand here. And then we've also got glass that in box section, the same way that this is in box section, but at a lower level, coming off of this steel, going there, and then a vertical meeting this steel here. This one is hanging in the middle of the air, but I can assure you it will be on a wall here. And then we'll have a 500mm gully section, which will take rainwater actually from the main house down this gully section and down a drain pipe here. So yeah, we've got glass that goes round there and comes towards us down here. And we've got this big 1 meter overhang. It doesn't look that big, but it is the actual back of the wall's about where my mouse is now. It's actually a set of glass sliding doors with a glass set of glass windows above the sliding doors that will go up and meet this roof. So as you can see, I've drawn this with furrings, and the design of the rainwater fall off is rainwater. There needs to be an upstand for this vertical section of glass here, so that's got 150 from the top of there to there. Rainwater will fall down here, and that's just a flat fall, and then it will go into this gully, and there's furrings that take the water in that direction, so from right to left. And then we've got another little bit here where I've put some furrings here as well, as you can see, so that bit just goes back into that gully. And so that's the rainwater design that I've kind of done independently of the architect, really. And that's what we currently have. You can't really see it from this angle, I'm afraid, but that is pretty much it. You can see this side bit of wall. We haven't put the steel on yet, but that's going to go on shortly. So my questions really are around the vapour control layer, because the architect has drawn a vapour control layer. So the build-up is a warm roof on this section. We've got steels, joists in the steels, plywood on top, well, furrings, then plywood, then a vapour control layer, then 120mm of Kingspan TR26, not 24, on top of that, and then OSB. Then we're having fiberglass, not rubber bonded roof. We're going to get a high quality installation of fiberglass roof. I'm going to see to it that that happens. I was toying with the idea of doing this myself, and I'm obsessed with the detail of these things, but I think actually getting someone who's very experienced with this would be a better idea. But I'd like to do everything else. So the question is, this vapour control layer that comes around here, first of all, I should say, because this is a warm roof, this is a kitchen, the warm moist air can come up here, and potentially it can come all the way out here. Even though this section is outside, there's warm air from the kitchen potentially going to be hanging around this area. So that's why there's insulation on this front section, and our architect has put insulation inside the joist as well. I wonder about that. What we need to do, it says 492 here, but actually our architect did not account for the fact that we need this big 150mm upstand at the rear, and he didn't account for 110mm of furrings at the rear. So this pushes it up to kind of 650 or almost 700, which is just enormous beast of a front fascia. And we can't, you can't possibly have that, because it would look quite ridiculous. So the idea that I've got, or that I've been kind of looking at, is, I'll see if I can show you my drawing. It doesn't really show it on here, but the idea, perhaps I'll show it on here, is that we have insulation on the main section over the kitchen, and then we just keep the insulation on the inside of the joists here to keep the bottom plywood under there, or composite, whatever material we use, to keep that warm, and insulation will keep this warm as well, hopefully. And we will still have insulation on the outside of this steel. We're going to have a piece of wood going right up against that steel to create the upstand with a little fillet there, and then insulation on the other side of that wood, and then another piece of wood. So much like he's drawn it here, actually. My question is, A, does the vapour barrier need to come all the way here, wrap around here and go back and meet that window? The reason I ask that is, what's the point of having the vapour barrier if it's not to stop, you know, warm moist air condensing on a cold surface, which this will be? So does that vapour barrier need to come round? That's question number one. Question number two, do I actually need to consider this section, and please try for now to ignore this bit of insulation because I'm proposing not having insulation on this section. Do I need to treat this as a cold roof, this little bit here, and vent it? Or can I treat it as a warm roof, or kind of some kind of hybrid situation? What's the best thing to do here? Or do I indeed need to have insulation on top and on the bottom, which would make this even bigger? What's the best way of getting around these problems? Those are kind of my questions, really. First of all, does the vapour control layer need to come all the way up and around and over and back and meet this glass? Question two, would I actually, or forget the vapour control layer here and just vent out and have some soffit vents? If I keep to this plan, so the architect visited site since he drew this up, and he said, oh, you don't really need this insulation on the top here. As long as you've got insulation on the inside, then you're going to be okay. But he didn't say whether we then need to wrap the vapour control layer around. And I've not really had an answer from him on that. So this is why I'd like to speak to or get the advice of a roofing specialist, hence me making this video. And then perhaps finally, I need to wrap insulation, put this plywood fascia on here, then insulate on the front of that plywood, and then another bit of wood, so that we can bring the roofing in a fully encapsulated system around and under. I'd have to do the same for this side bit as well, and obviously there's going to be a junction here because there's going to be glass coming down. You can't really see that on this diagram, but there's going to be a vertical glass coming down there as well. So do I need to insulate on the outside of there? Currently what I've got, I wonder if I can show this to you without kind of losing my view. Zoom into here, and then back out again. Oops. Yeah, so I've actually put insulation up against this steel on the inside, even though this is outside the house because this is an overhang. I've insulated the steel because I understand that we need to keep this steel warm, because otherwise we're introducing a cold bridge along this steel, because this will be outside and then this bit of steel will be inside, so it's one long steel this is. So we'd introduce a cold bridge unless we keep all of this steel structure warm. So is it right that I need to insulate on the outside of the steel and on the outside of this steel? Does it harm it if I put the insulation on the inside and the outside? Kind of belt and braces, or is that just a terrible idea? And the same around the side here, of course. So yeah, I've posed a load of questions. I'll see if I can break it down just quickly to recap. First one, do I need the vapour control layer coming all the way down here, dropping into this gully, back out and around and under and meeting the glass under here? That's question one. Question two, should I indeed insulate over the top of this even though it's on the outside, or can I get away with insulating on the inside as long as that insulation goes up against these boards? Question three, would I need soffit vents? And if I need soffit vents, do I also need to have the vapour control layer? And question five, where should I put the insulation? Should I put the insulation along the front? I think I should, and along the side, but should I also put it on the inside of these steels as well, inside the roofing structure, which is on the outside of the house? It's quite a complicated roof. It's turned into quite a complicated roof. I thought this was going to be very easy, but all these questions have arisen because I'm not a roofer, but I do want to make sure I get this right. Unfortunately, the task is down to me to do this. I've been in touch with roofers, but I haven't really had good detailed answers about these questions yet. So yeah, hoping you can help. Thanks for your time.